All right. Thank you, everyone, for being here. Welcome to our third event of Earth Week by Astrobites 2024. I'll let you guys take it away.
All right. Okay, so I need to welcome everyone to the event. I think we can start with Hilding. Right, so feel free to share your part.
Hi everyone. My name is Hilding Neilson. I'm a professor in the Department of Physics and Physical Oceanography at Memorial University of Newfoundland and Labrador in St. John's, Newfoundland and Labrador, Canada. And I still need to find a way to shorten that because it's very, very long. If you're wondering where that is, St. John's is the northeast tip of what we call North America. And if you remember the total solar eclipse just a few weeks ago, we were just at the northeast end of it. So it was kind of fantastic. But there's not a whole. I'm one of the few astronomers here, largely because this city is nicknamed Fogtown. So you can imagine observational astronomy doesn't go well here, unless you really like observing water. My journey to astronomy begins, when I was 18. I grew up in a small town on the west coast of Newfoundland, also called Dadamaguk in Mi'kmaq. The town's called Pasadena. So that might mean I'm destined for astronomy, given its connections and relationship with Pasadena, California, and all that stuff. But as I went through school, I went through all the traditional ways as any settler people would in North America, and went to university and fell in love with astronomy and earned my PhD and traveled the world. But when I came back and started teaching as a contract professor, I started noticing and realizing and appreciating the lack of indigeneity in our astronomy curricula, whether it is our Astronomy 101 type level courses or our advanced astrophysics courses. Indigenous knowledges, particularly from my perspective, peoples from Turtle Island, were not present. We would talk, you can open up a textbook. It would have 2 pages on historical and astronomy people, and one of those pages is probably either Easter Island or the pyramids in Egypt. And this was very disappointing and challenging. So a lot of my work in the last decade has focused on trying to think about how we can do astronomy through indigenous lenses and through using indigenous methodologies. And that has led me into working in groups with the IAU on protection of the night sky, the International Aeronautics, working on SETI and how we think about that. And a lot of these ideas are thinking about how we can use indigenous knowledges. And this is very important when we think about on Earth Day or Earth Week and environmentalism, because most environmentalism in North America has fallen on the shoulders of indigenous peoples, whether it is Standing Rock, Hawaii, and Wet'suwet'en in Canada, and so on. And so thinking about how we can be decolonial and anti-colonial in our environmentalism and astronomy is an important way forward as we become better and astronomers and better people on this world. Thank you.
I was muted, sorry. Right, thank you, Hilding. I'd like to invite Azadeh to say a few things as well, if you want.
Sure. Hi, everyone. My name is Azadeh Keivani, and I'm by training an astrophysicist, currently a data scientist, and also kind of like a social impact entrepreneur. I run an educational technology nonprofit that is currently kind of pivoting and going towards creating more digital contents and a series of science documentaries. I also do data science currently as a consultant. Previously, I was in healthcare in different hospitals in New York City. I live in New York City. I'm originally from Iran, and I have been an astronomer or astrophysicist for a long time, since 2008 that I came to the US for graduate school. And then I stayed in academia for 12 years before I changed career and starting my educational technology nonprofit, and also entering the world of data science. So I guess I'm here today because I co-founded Staryab, which is an astrophysical literature website written in Persian language, in Farsi, for Persian-speaking students. in 2014 with my friend and colleague Irene Shivai. And since then, we have been writing articles and recruiting authors, and now more younger folks write like astrophysical articles for the website. But mainly it's like very similar to Astrobites. It's either like summarizing professional astronomy papers in simple, understandable language, or we ask our Persian astronomers to write about their own research, or sometimes like they even record something and give a webinar, and we upload it into the website. So I'm here and so happy to be here with you, with all of you.
Right, great. Okay, so right. So for this year, our theme is centered not only on the intersection with astronomy and climate change, but we also want to bring in the perspective of indigenous science, and in contrast or in collaboration with Western science. So what we want to think about with our Earth Week event is how this intersection of these three themes, how this can help us, how this can change our viewpoint, how this can impact or how this can change our view on science, on how we how this informs our work and our life. Yeah, from these three aspects. So yeah, I would ask you if you can elaborate a bit more on that. On what's your point of view on that? You can start with Hilding.
Oh, thank you. I think, yeah, it's very important to do the intersection. And when you were speaking, it reminded me of the story from a few years ago, where a number of Inuit elders noticed that the stars had moved. They had shifted to the night sky, and that was strange. And they talked about it loudly, and it became in the press, and people kind of dismissed it. And some NASA scientists kind of came to the conclusion that it wasn't that the stars had shifted, but because of the changes in the atmosphere in the north, because of climate change, the stars twinkled and refracted differently. And so all these things include, Western knowledges and indigenous knowledges, and they tell us that things are happening, and these things are connected to the land. One of the things I've worked on as a scientist is this idea of the space and land being related. Land, capital L, land. That where you are on the Earth is reflected in the sky. If you're in Mi'kmaq land, in the Mi'kmaq, you have constellations like Muon and the Bear Hunters. If you're Cree in central Canada, you have a great bear hunter. If you're in South America, you have dark constellations like the Llama, and so on. And these constellations reflect different times of the year. They reflect different environments and climates. And the changing climate on Earth is changing how we view these stars and these dark constellations. This is telling us, these knowledges are informing us that the world is changing in ways that we can't necessarily predict, whether it is through wildfires and so on. So thinking about these methodologies and how we think about indigenous knowledges is very important, because indigenous methods are very different than Western. Indigenous people think in many variables, whereas in Western we tend to think in one variable. Like if you do a first year physics exam to measure gravity, you just hold everything constant and move a ball higher or lower. Or we think about relationality versus objectivity. We like to think in astronomy we're objective. I observe that star, I create a theory. You should be able to replicate that observations and replicate those models. But a lot of what we do is reflective of who we are and our own biases. And so having these methodologies allow us to think a little bit differently than Western methods to how we relate with the environment as well as the sky. And as astronomers, I think we have a responsibility to talk about that, because we have a bigger picture of the Earth, but not just Venus and Mars, which are both climate change victims of their own right, but also around planets of other stars, how stars evolve, how we relate with asteroids and meteorites and so on. And having these discussions with knowledges that go beyond just the traditional Western, it's also very important to think about how we can have solutions to survive climate change, maybe to reverse climate change. These all come from different methodologies, as well as, in many respects, different timescales and different belief systems.
Great. Yeah, very, very interesting. Does Azadeh, you also want to elaborate?
Sure. Yeah, I mean, there are a lot of things we can definitely talk about and discuss here. But the other day, I was thinking that many of us, like as scientists, try to practice our own behaviors, like change our own behaviors and lifestyle to be more environmental friendly and like be more thoughtful about climate change, which is very, very important, and I appreciate it. And then all the little marginal effects that we might have suddenly get completely destroyed by the wars that happen. And unfortunately, we live in a time that we are observing a few different wars around the world. And every bomb that goes on top of like people's head creates a lot of pollution and destroys human life, animal life, and then creates like a really polluted environment and is not, just environment friendly in any aspect that you think about it. And it's just from human level, from climate level, from everything that we can think of. So this is, I mean, we are talking about climate and astronomy, and we don't want to get involved in politics many times in many occasions. However, I think they're very correlated. So you think about some people might say, oh, I just want to do science. I don't want to get involved. But like, okay, if we try not to use another plastic bottle today, how many of us on this planet for how many years should not use plastic bottles? And how do you compare it with just one bomb that goes like on top of some people's head in one city and like create all these pollution? So these are all correlated, and we have to, as scientists, we have to estimate these things. We have to take action on these things. We have to talk about them. We have to be like more open-minded, and maybe like if at any point any of us go to science policy or going to conservatories or climate policies, then we can have our own impact. So it's important to have like that, back of the envelope calculation and say, hey, like what is the impact we are seeing at this point? How can we raise our voices? How can we talk about it as scientists? So that's one thing. But on the other side, like wearing my Persian hats, I can also say that a long time ago, before Islam even came to Iran, we had different cultures in Iran. One of them was Zoroastrians, as you might have heard the name. And this goes back to maybe a couple of thousand years ago, where interestingly, very recently, I realized there were kind of stories and myths from those times that talk about the creation of the universe and the planets and the constellations and all of those, things that people could observe in the sky. And they are very similar to the Greek myth and the Greek stories and Roman stories, but they're very separate. They're like in different times and completely in parallel and separated, but they're very interesting, that the concept of like thinking about the universe and creation of the sky in different levels and assigning each planet to a god, or like to good and bad, and thinking about Mars being the god of like Saturn being the god of war, Mars being the god of something. Like it's so interesting to like observe this, and I realized that, wow, I personally as a Persian, I always heard about like Greek myths and Romans and like other Western countries, but not Persians. And that the one reason is, of course, because many books got destroyed during several fires that happened, and because of the wars between Persia and other countries. And But there are still some documentations on the rocks in different areas and on some books that survive, which people had started putting them together and learning about indigenous in that the people of those eras in those parts of the world. So, and then I can definitely tell you more about how Persian indigenous astronomy has different stories, and how it impacted the more Western modernized science that started from about 500 years ago or so.
Great, very interesting. Thank you, Azadeh. That actually connects pretty well with our next question. So, staying in the theme of science storytelling, I mean, this is also an important part of what we do in Astrobites, right? What also our sister sites with Startup do as well. But it's also really important in doing science in general, right? What's the background? What's how does this come to be? Now, I was wondering if you could elaborate a bit more on this storytelling, how this comes up in your work and your life, or if you want to share one of these stories. Yeah, we can start with Hilding, please.
Yeah, thank you. There's lots of different ways we tell stories. We tell stories in our research papers. We tell stories in our classes. We tell stories to each other through various written oral traditions. When we were speaking beforehand, I work in stellar astrophysics fairly often, and every time I find this almost constantly true. Every time we get new information about a star, it usually means we know less about that star. And because every star has its own weird behaviors and its own stories. And when we write a paper, we're telling a story about either that object or galaxies or cosmology or data science. And those stories are all different. From indigenous perspectives, these stories are ways of transmitting knowledge, and they can be done in different ways. So for instance, in Mi'kma'ki, in the Northeast, we tell the story of Mune and the Seven Bird Hunters. And this is a constellation story. But it's not like Orion, it's not like the Big Dipper, it's a story you tell throughout the year. In this story, it's related to the Big Dipper. So the 4 stars of the Big Dipper is a bear, and then there's an arc of 7 stars behind, not just the 3, that are the bird hunters, starting with Robin. And we tell this story early in the morning, around 5:30 or so, because as you go through the night, of course, the Big Dipper goes around the North Celestial Pole, so you can't. But if you watch it at the same time every day, it goes around again in a different timing, the same path around the North Celestial Pole. So we tell the story early in the morning, a bit early for me, but each their own. And so in the spring, Mune is kind of pointed downwards because the bear is waking up. Mune is waking up, tired, long winter sleep, feeling a bit hungry because you sleep for a few months, you're going to wake up and have some hunger pangs. You're going to want something to eat, whether it's berries or McDonald's, I don't know. And Mune emerges from her cave, her den, and starts looking for food. Robin spies Mune and knows that Mune's meat will feed people, its fur will keep people warm, its fat will be medicine. And so Mune calls his friends. Robin calls his friends. And quickly comes Chickadee carrying a basket, followed by passenger pigeon, gray jay, blue jay, barn owl, and sahuat owl. And it's worth noting that passenger pigeon is one of these birds doesn't exist today. It is our cousin who is our kin who is extinct because of hunting and humans. They begin hunting the bear. And as we get into summer, the constellation is sort of flat in the sky. So the bear running across the land, invading the hunters, and they're being very outsmarting them at every turn. But eventually, as this long summer passes, Mune is getting tired and frustrated and angry. Some of the owls have lost track of the hunt because they're below the horizon at this time. So Mune's frustration gets on her hind legs and growls at Robin. This is Robin's chance. Robin fires an arrow, striking Mune in the chest, and blood goes everywhere. Blood covers Robin, and Robin flies into the trees to shake it off, turning the leaves red except for one spot on Robin's chest. Mune passes on. Mune dies. and the birds come together, chickadee with his pot, and you see this in the stars because chickadee and the pot are two separate stars in the sky. Chickadee with his pot, start cooking meals, they build a fire, the other birds join, they start singing and dancing and sharing stories as we move into the winter. And in the winter, Mune is in the sky on her back, waiting for the spring to reemerge in their cave. And this story is important because it's about science, constellations, it's about community, it's about biology, it's about ethics. You do not hunt a bear in the spring and the summer, you wait for the fall after, after it has cubs and after it does all of its duties. And so in this respect, we learn a lot about science, we learn a lot about the land because these birds are native to those lands. The bear is native to that land and is an important companion and source of a being. And it's also a story about relationships. We live in treaty with those birds. We live in treaty with those bears. We don't take more than we can eat. We don't take more than we can use. We don't abuse the lands and the homes of the bears or the birds. And so there's all kinds of science and stories there. And we tell stories in similar ways in Western science. We write them down. We might start with a section called introduction. We'll start with a section called methods. We'll end with summary, probably with the sentence, more work is to be done. But we're telling a story too. And those stories are important because they also can be related to who we are and our behaviors and our ethics. And this is much more important for science, particularly astronomy, as was noted with the impact of wars, because in science, we tend to think of science as either neutral or benevolent. We're astronomers. We're bringing the sky to the world. Come on. We're doing great things, but we're also doing bad things because that science that brings the sky to the world can be used by companies like Boeing for bombs, can be used for companies to do pollution, can be used for colonialism, and more. And so we should be thinking about our stories also from an ethical perspective on what they mean and how they can be used. So thank you.
Yeah, thank you very much. I mean, it's great to hear how much you can take with, well, a simple story, if you will. It's not only the movements in the night sky, but indeed, like you said, all these extra teams, all these extra connections that you can do with it. Yeah, it's really great. All right. Azadeh, I don't know if you also want to.
Sure. Yeah, that was great, Hilding. I really enjoyed the story. There are a lot of stories that we can always tell about our science, and especially these days with huge amounts of data that could potentially impact some people. So let me elaborate a little bit on that. So as an astronomer, of course, I used to attend to different conferences and workshops and meetings, and we all know that we have to tell the story of our work in a way that other scientists can kind of relate to. But that's not the hardest way to tell a story, because usually when you start talking about your scientific outcomes and results, you have audience who are already interested in your work and are already knowledgeable about your work. So the challenge comes when you talk to some kind of non-technical audience. So we can actually think about non-technical audience in two ways. One is when we, as astronomers or scientists in general, do outreach activities. So in outreach activities, when you talk to kids or to adults who are non-scientists, we have to have different voices. We have to start from where they are and start telling them stories that it starts from their curiosity, first of all, especially for kids, because kids are more brilliant and more curious in general than us adults. So it is always very important to see what questions they have in mind. There's so many questions they always ask, and then start from somewhere that they can relate to and they can appreciate that information you are giving them, and then you walk them through whatever you're trying to accomplish in a way that they at the end of the day, they're more curious and they have more questions. Unfortunately, in the real world, we see that as kids, and then we get to maybe like from elementary school to high school and college, we gradually lose our curiosity because this education, the universal educational system, unfortunately, is not encouraging you to stay curious. And then when you get to graduate school, then you kind of have lost all of your curiosity, except that you know you have to solve this problem, which is amazing. But then sometimes it happens that you're like, I don't care about anything else. I don't care about, like, I remember when I was a graduate student in astronomy, I was like, I'm too cool to go to condensed matter seminars. And that was a mistake. And now I'm telling you, at some point I realized, wow, different sciences are so interesting and we can always learn from other people, from other sciences, and generate new ideas when we go to a biology like seminar or talk, or read a public science book in neuroscience. And you know, there are a lot of different sciences, and even engineering and even finance and even like arts, that if you start like paying a little bit more attention to, even as graduate students, you even like either it's not like you don't I'm sure you don't have enough time for all of that, but even a little bit of that will suddenly create and ignite some new ideas about how you approach solving the problem, the thesis that you're working on. Then continuing on that, like science storytelling, sometimes, like me, you get to go work outside of the academia. And since I started working in an industry, I realized that, wow, it's so hard to tell stories to people who are not in my field. I was working with professionals, but in a team that we had engineers, we had designers, we had product managers, we had program managers, people from all different professional backgrounds. And then I realized that although I always thought I was a great storyteller and I could share my stories with the science community, now I'm like, wow, when I talk, people are like, what? Like, we don't get it. And then from the questions that they are asking or from the reactions, I was saying, oh, I was not doing a good job. And this is another level. So you have to think of how to tell your stories, science stories, in a way that is accessible to other people too, to professionals who work with you in the same team and the same project, but you have a different language. I mean, you cannot just go there and use like jargons that we naturally use in astronomy and physics. Definitely have to explain what you're talking about, and again, meet people where they are. So that's another part. But then kind of following up on the previous question that I was talking about, Persian astronomy. One thing I really like about current maybe Persian events and calendar in general is that it is really correlated with nature. So long time ago, again, in about 1,000 years ago, but this time after Islam, in Iran, there were Persian/Arab astronomers who started studying the sky very accurately. They started like sketching the objects and like recording all the measurements of the exact position of the stars and planets for a very long time. They created observatories and created instruments to actually measure the precise locations of the objects in the sky. And as a matter of fact, in parentheses, I should tell you that Staryop or Astrolabe, or in Farsi, or Storlab, is the name of our website, but it's also, in fact, originally it's the name of an instrument that was built to measure the location of objects in the sky and the time. So that instrument was invented by Persian astronomers, and then they created a calendar that was very precise. But one thing that was very interesting to me was the way that they started the year in the calendar, and that starts with the vernal equinox. for the spring equinox, which is usually on March 21st. And now we know how to precisely measure that to second level for the calendar purposes. But at the time, the way that they used it was that the first day of the calendar is when we have the sun entering the Aries constellation. And if it happens before noon, before we see the sun in the sky from the calculations, then we call that the first day of the year. And if it happens after midday, we consider the next day as the first day of the calendar. And then gradually they built different, Persian astronomers built different events and incorporated them into the calendar for people in the country and in the society, I guess, at that time, which were all aligned with astronomical events. So Persians were celebrating a spring equinox that is called Nowruz, or New Day, the first day of the year. They celebrated the summer solstice, the autumn equinox, and winter solstice. And that was like very interesting to me. And to this day, Persians across the world and also inside Iran and many other countries, Afghanistan, Tajikistan, Uzbekistan, different parts of these countries, they also celebrate Nowruz as the beginning of the spring, not necessarily the beginning of the year in different countries, but at least as the beginning of the spring and when everything gets new and very fresh and nice and beautiful. So yeah, that's it. And I think definitely continue.
Great. Thank you both for sharing that. And yeah, sounds like this sharing this storytelling stuff. It's not only good for bringing to a wider audience, but from the things you said, it's also in some way, I think it could maybe even apply to some educational, not only high school wise, but also university wise even. That it has a lot of educational value too. Also, not only for students of astronomy, but literally anyone who's interested. Maybe we should start conference talks of like stories on any of these kinds. All right. Okay. So based on this storytelling, how would you try to connect this back with, or how would you try to connect this, or how would you use the storytelling to raise awareness for climate issues, for example? I mean, yeah, it's inherently I'm searching for words here. Inherently, it's great to wake up some interest in people for the topic you're discussing about, but could you also discuss on how this would couple to environmentalism, on climate issues, on these problems we're facing today? Yeah, I guess we can start with Hilding if you want.
Sure. I guess from your question, and I was reminded a couple times about this, is when politicians walk into a building in the middle of winter and throw a snowball and say, "Look, where's your climate change now?" Or in Canada, they complain it's cold. Where's your climate change now? And they're telling a story too. They're telling a story that's very short in time, very specific to a moment, but it's also one we all recognize. If you live, in northern North America, you know what it is to shovel snow, and most people do not like it. We know what it is to have lots of snow, or to have flooding, or to have storms or hurricanes, and we've had them before climate change, and we'll have them now in different ways. But the stories a lot of times get told from people who are anti-climate change are stories of a present moment. And so I think when we tell our stories, we have to think about what our stories are in terms of time. So one of the stories we have in Mi'kma'ki is the stories of our moons. our similar to Persian calendars, we have our different months that are based off the different lunar cycles, and those moons have names. Sometimes it's ice breaking time. Sometimes some months are berry picking time. At the winter solstice time, it's the elder moon. But almost all of the moons relate to various times in the climate. And for instance, on the month of ice breaking time, you do not want to go out on a pond because it's dangerous. But if as climate change gets worse, the ice structure is getting more random, more dangerous. Ice is melting earlier in the season, and so that story is being broken. So thinking about how our stories that come from eons or millennia, generations can work is very important in how we tell that. But when we want to talk to, maybe the disingenuous people who throw snowballs, we want to tell stories of, what is this like where I grew up. I grew up in a town that had a ski hill. A ski hill now barely gets a few months a year, as opposed to 6 or 7, which, given that I'm on the island of Newfoundland, which is about the same latitude as Hungary, Germany, and so on, that's kind of scary. Or the idea that temperatures are less frequently cold in the winter, warming in the summer is a very problem. Or telling stories about the permafrost in the north, about how the structures in the far north are sinking because the permafrost is melting. So noting how things travel in time and cycles is very important. I think if we want to convince people to have that change is necessary, we also have to meet them where they are in terms of, we all have different worries. Some people worry about inflation, whatever. There are a lot of big problems in this world, and we have to meet people where they are. Sometimes we can't meet people on the climate, particularly if they're in war zones. Who cares about environmentalism then? But if you're in the U.S. or in Canada, we sit in it. We could talk about environmentalism all day, but then we have to think about, what does it mean to feed our families? What does it mean to have jobs? What does it mean to have an Xbox? You got to meet people at the Xbox too. And so having those stories should reach people, not intellectually, but here in their heart and their wisdom. And that's not always easy, particularly for science, when we tend to think very quantitatively. We tend to think in senses, there are 15 galaxies in this group, and that means something about dark matter, who knows? And so, but what does that mean in terms of our spirit? What does it mean in terms of our future? Is something where we have to reach people in the heart. And that means also transitioning from just pure knowledge, which a lot of Western science is built on the study of just knowledge as something you obtain, but also think about how we use knowledge, how we build wisdom in telling those stories. And that's also means learning how to live in relationship with that knowledge.
Yeah. Yeah, I agree. Certainly. I mean, I'm also reminded, if I can throw some personal stuff in here as well. I'm also reminded of my talking to my grandmother about the same thing. That she said, it used to snow for months in northern Belgium, where I'm from. Now we barely get some wet drizzle in the coldest months of the year. Yeah. I mean, it seems this kind of stuff is you can hear everywhere at this point, and yeah, it's easy to connect around, I think. Right. Yeah. Sorry. I don't know. To say a few words.
Sure. Yeah, absolutely. So just I want to maybe add to what Hilding already nicely explained. So, for example, as astronomers, we are aware that there are Milankovitch cycles that change the orbital characteristics of like each planet, and then depending on the, for example, tilt angle and like different rotations, you get different amounts of sunlight, right? So many people, many like maybe anti-climate change people say, well, yeah, look, these are all the astronomical events that happen, and that's why our planet is getting warm now, and this is like the maximum. So think about how, as an astronomer or in general scientists, you would counter argue against that. So these are the elements that are very important, in my opinion, that as scientists we have to be well aware of. And in case there is a discussion somewhere in our family, friends, like on social media, anywhere that you want to get involved, and something like this comes up, how you would approach this problem, how you would provide different answers. So of course, it is, I should say first, like disclaimer, it is not easy to convince someone who decline and rejects like the scientific facts, because no matter what you do and what you show them, they will come up with some excuses and they don't listen. But it's not for everyone. Sometimes it might be impactful, it might open up something in their mind that they can like perhaps do some more reading themselves, and it's the effect is not zero. It is a positive effect if you are aware of these things and talk about them. So for example, I used to work for the Ice Cube Neutrino Observatory, which was in the South Pole. So I like things about the South Pole. So scientists actually go to the South Pole and drill down the ice and bring out cores of ice. They call them ice core. And then it's like for in Antarctica, there are different layers that they can dig in and bring the core out and study different layers, which date back to 800,000 years ago. That's really so long. And then based on different isotopes of oxygen within each of these layers, they can estimate the temperature at each year, at each season. And then when you plot the temperature change from 800,000 years ago all the way to today, you see very interesting patterns. And you're like, okay, all of these astronomical cycles were for like 23,000 years or 100,000 years. What if we look at the data of 800,000 years? If what you say were correct, you have to see something that is just fluctuating every, let's say, 100,000 years. But then we see something that is fluctuating, and then in the last 150 years, it suddenly go up in the plot, and it's really above the statistical fluctuations. We are really seeing one point something, 2 degrees Celsius difference between what we had usually, what we can fit as a uniform line, to what we have been observed since we have been observing since last 150 years when we had the Industrial Revolution. So these are the things that are very important. You can do the same thing with CO2 concentration. You can do the same thing with like water level. With those so many different factors in the on planet Earth. And this takes me to the point that I would like to emphasize here, and that is, I don't think we should only focus on astrophysics or astronomy as astronomers. We have to be scientists. We have to have a little bit like general knowledge in different fields. Again, going back to my point of like go to different seminars, like and read books and talk to people, talk to your friends in different departments, and go to like a Nobel laureate in different, like in other fields talks, because they're usually like more general and more understandable, and try to educate yourself as much as possible, because in that case, if something like this happens in any domain, you're not like, oh, sorry, I'm just an astronomer, I cannot like comment on other scientific facts. In fact, you can, and you have the basic knowledge by studying so much physics and astronomy, and by learning so many fundamental concepts and building blocks of science that really equip you well to excel in different fields. So yes, that's that's how I personally see like the connection of astronomy and climate science and how we can play our own maybe tiny role in this world.
Great. Yeah. Thank you both again for your viewpoint. I also want to ask the audience if there's any question from your side. So yeah, please type in the chat or let us know. Right. So okay, if there's not something coming immediately. I mean, this also brings up.
So maybe
go ahead,
sorry, go ahead, Ro. No, for the questions, I just wanted to say,
Yeah.
maybe we should ask some brave students to speak up and ask their questions, so that we feel it's like a communication, like a two-way communication.
Sure. Yeah. Okay, if there's nothing coming immediately. Yeah, so what you all said, I mean, wait, I think I see something. Oops. Yeah, so Suchi asked, what role can storytelling and oral traditions play in raising awareness about the urgency of addressing climate change? Yeah, no, to elaborate on that, we can start with Hilding again, if you want.
Sure, I think it's absolutely important. And we talk about, we use different kinds of storytelling of all sorts in terms of climate change. In some respects, the new series Fallout or zombie TV movies, The Last of Us are all kind of climate change stories. And, so whether it's fiction, whether it's historical, whether it's everything, storytelling is completely important. And I think with respect to oral traditions reach back thousands of years. An elder, Leanne Merkel, once spoke about how she visited Mongolia and spoke with people on the steppes, and they were speaking very similar languages, like they could understand each other, and the stories were the same, suggesting that the stories were at least 40,000 years old. Dwayne Hamacher, an astronomer in Australia, who I think was on the Astrobites podcast, talked about some of the first stories. There are Paiute stories of the North Star moving around. So those stories are over 1,000 or a couple thousand years old because it talks about the precession of the Earth. And so this allows us to reach back in a different way, thousands of years, just like the hockey stick diagram, and understand differences of climate, differences in environment, reaching back to different environmental catastrophes, such as the story of Sky Woman, who's sent down from the sky, and turtles build up Turtle Island, or or Raven, the story of Raven, and so on, because these stories exist too, or the flood story in the Bible, or the various other stories. And so I would say oral traditions are important. I think students should be engaged in these readings. I think bringing in other alternative, non-traditional or non-Western traditional readings is incredibly important. And yes, students should create their own stories. Why not have students engage in other ways of storytelling? If for no other reason, it engages a different part of their brain. It requires them to understand what it is they're talking about and why it's important, and bring in an ethic and a wisdom. Because, like as noted, people have to understand where we are. And so if you take the people like flat earthers who will not agree to any data because they believe the earth is flat, well, if you want to talk to them, you still have to meet them somewhere. You still have to meet them in their beliefs, in their own histories. In many cases, it could be traumas and so on. And you have to meet them where they are at. And you have to talk, and the biggest part of storytelling, I think, is also listening to your audience, because your audience is the people who you want to engage with, you want to take something away from your story, whether it is the urgency of climate change, or the earth is round, or cosmology is cool. Listening to what the audience says is also incredibly important, and hearing their stories, and even whether or not we just agree or disagree or think they're silly, but to listen is very important. Thanks. Thank you.
So I think I can comment on the second question, because the first question has been answered really nicely. So for the second question, I have been working with college students and high school students for a long time now. And I think definitely providing engaging readings and documentaries and movies would be very helpful. But one thing I have found that is extremely engaging in classroom is to, again, with storytelling, start raising a question, but walking the students step by step through problem solving, but not telling them the final answer. This engaged them so much because when you ask kind of like not too easy but not too hard questions from them step by step, it makes them think, but think enough that they can find the answer. And then you move one step further and raise a new question. And then you kind of like create a whole set of problems in their mind that now they can pick one and go about researching and reading up on that and find some answers, or like even provide their own thoughts. So I would say this is a very good method. Actually, in education, there's always like in education research, there's something that I don't know what it is called, but there's a method that say there's like a very narrow layer in learning, that if you teach people things that are too simple, they're not engaged. And if you, even asking a question, and if you ask a very hard question or teach them something that is very hard, then again, it's not engaging. You have to find that narrow band so that people are curious in that band, but cannot immediately find the answer. So they learn something, but they don't learn everything. So now there's room for their own self-education and exploration and thinking.
Yeah, yeah, I agree on all those points, of course. Right, so all of this is also couples back on kind of our theme for our Earth Week here, right? On also what we want to do with our climate change committee with Astrobites. It's kind of this community building as well, and I mean, storytelling in general. I mean, to literally anyone. I mean, the audience you engage with students, people you might disagree with, even this can help to bridge this distance you feel between anyone you're talking to. Now, on that aspect, and also this intersection between of astronomy, climate change, and indigenous science and indigenous backgrounds. How do I phrase this? Would you think this is something, or would you think this would be a good practice for astronomers, for everyone to use the storytelling for community building, for connecting, not only for audiences like in conferences, for example, with people you already engage with very closely, but also with everyone? Yeah, with anyone you talk to, people you disagree with, people you agree with, anyone in front of you.
Yeah, I think so. I mean, a lot of the ways we talk about things are born in the language we use. So for instance, we love to talk about study and search for life. So then when we talk about study and search for life, we have to define something called intelligence. Then we have to define something called life. And these things are not readily, obviously apparent, and change depending on your perspective. You know, for most people, the intelligent species is humans, which, given climate change, our behaviors to each other, probably not the best definition. I'd prefer to think of cats as being the most intelligent species, since we take care of them, we clean about them, and they basically scratch us. But, you know, or life. how do we define life solely based on DNA? Do we define life as a relationship? Could the moon be a living species, a living being? Could water be living? And these change how we relate to them. And so telling stories is about how we use language and allow us to change that language. So that when we want to talk about climate change, we're talking about how we interact and have relationships. So for, if water is life, if air is life, then that means, we have a different responsibility to talk about pollution, to talk about climate change. If we talk about intelligence as being solely human, then we change our responsibilities a different way, in that we become only responsible to ourselves, not to nature, not to plants, not to water. And so I think stories are important because it also comes down to how we use language, how we think and operate in a conference or in a science outreach or in a storytelling. The language tells us about a lot of where we're coming from and where we're going. And I think building those differential from different ways, such as Western knowledge and Indigenous knowledge, is important because, the Mi'kmaq elder Albert Marshall defined this concept he called it two eyes seeing. One lens is Western science, one lens is Indigenous knowledge. And you bring them together, you could do deeper and get a deeper vision of the world around us. So bringing everything together and telling these stories allow us to be better scientists, be better astronomers, and be better humans.
Yeah, totally agree. I think like it's very important to build a network in general and do networking everywhere you can, from different aspects. Like you learn new ideas from people and you gain new insights, and you can actually combine different ideas and your knowledge from like astronomy with climate science, with biology, with biodiversity, like all different sorts of like fields. But also on a personal level for career growth, I know that we have graduate students here, so you might think of like what's next. So for the career growth, I think it is extremely important. So it's like the number one factor that make your career growth and like job hunting more like easier. So I would say that in general, like if you try to build your network anywhere you can, including on LinkedIn or in conferences or in different events across your city, like outreach events, career fairs, like any kind of networking opportunity, that would be extremely helpful in your science work, but also your job hunting.
And I just want to add one thing to that. Networking is terribly important, but so is your health. I know that when I network too much, I get exhausted because I am not that kind of person. And so I just want to make people sure, build your network, but make sure to don't exhaust yourself doing it. Make sure you save energy for yourself. Likewise, for advocating for changes, environmental policy, environmentalism, educating climate change, take care of yourself, because that work is going to exhaust you if you put everything into it. And so the best way you can help with education and outreach and networking is also to take care of yourself.
Okay, thank you both so much. We're at the top of the hour. I just wanted to wrap up. I was really struck, if you don't mind me chiming in, how often in this session and then the other two sessions this week, how often the concept of relationships came up. Not only our relationship to nature, our relationship to ourselves, our relationship to each other, these themes of building community and recognizing the reality that is the interconnectedness of things. And I think that is something that we are taught to dismiss in sort of Western science academic settings, to have this like purity of science and devaluing relationships when that is in fact in conflict with reality. We are fundamentally in relationship with nature just by being alive. And if I can sort of paraphrase what I think some points you both have been saying, I think remembering how fundamental that relationship to Earth is can help us be better scientists and better advocates for the climate and better humans. So I just want to thank you again for your words and thoughts today and for your time. And thank you to the audience for being here. If there are any other questions or if either of you have any last thoughts, otherwise I will wrap us up.
Not much, but just want to say that feel free to reach out if you had any further questions or need any advice or anything that from my experience I can provide.
Thank you so much. Yes, we will be posting the recording and the transcript of today's meeting shortly, and as well as a summary post with any resources that were brought up and link to both of your websites. Folks can contact you. So thank you everyone again for being here, and we have one more event tomorrow that will wrap up Earth Week 2024. Thank you.
Thank you.
Bye everyone.
Well,
Thank you.